When we see a molecule, we describe it by its formula. A molecular formula is the actual formula of a compound. Glucose is C6H12O6. However, we have another thing called an empirical formula, which is a reduced form of the formula with the smallest whole number ratio of atoms present in the molecule. We can divide them out, C6H12O6, to make CH2O. There are twice as many hydrogens as there are carbons and oxygens. Those subscripts tell us how many moles of the substances there are. Those are mole ratios. We can take numbers and data from labs to calculate the formulas. Let's start with the empirical formula. Let's assume we're trying to calculate the empirical formula of glucose, and we know that glucose is 40% carbon, 53.3% oxygen, and 6.67% hydrogen. Here are the steps we would do to find the empirical formula from this information. 4 basic steps to finding the empirical formula. First, we need to assume we have 100 grams of sample. That allows us to turn the percentages into masses. If we turn those percentages into masses, 40% of 100 grams tells us we have 40 grams of carbon. We have 53.3 grams of oxygen, and we have 6.67 grams of hydrogen. The next thing we do when we have these masses is we need to convert them into moles. The empirical formula is a mole ratio, so we need to convert these to moles. To convert the carbon into moles, we take 40 grams. We know that 1 mole of carbon is 12 grams. And we do the calculation, and we find 3.33 moles of carbon. We do the same thing for the oxygen. 16 grams is 1 mole of 3.33 moles of oxygen. We do the same thing for the hydrogen. The molar mass of hydrogen is 1 gram per mole, and so we have 6.67 moles of hydrogen. Once we know the number of moles, we need to find the mole ratio. In order to find the mole ratio, we take each of these and divide them by the smallest. So, I'm going to take 3.33 moles of carbon divided by 3.33, and I get 1 for carbon. Do the same thing for the oxygen, and I get 1 for the oxygen. Do the same thing for the hydrogen, 6.67 divided by 3.33, and I get 2 hydrogen. These are our mole ratios, so we can now see we have C1, H2, O1, and that's my empirical formula. For this problem where we're given the masses, we can skip the first 2 steps of the procedure and go straight to the third one, converting the masses to moles. We have 13.5 grams of calcium. We need to convert that into moles. The molar mass of calcium is 40.1 grams per mole. We do our calculation, and we get 0.337 moles of calcium. We do the same thing for the oxygen. 10.8 grams of oxygen. And do the same thing for hydrogen. Divide each of these by the smallest, which is 0.337, and we get 1 calcium, 2 oxygen, and 2 hydrogen. You can see we've rounded a little bit, and now we have a ratio of 1 calcium to 2 oxygen to 2 hydrogen, and we have our empirical formula. Once we have the empirical formula, however we get it, whether it's given to us or we just calculated it, we can now find the molecular formula. if we know the molar mass. So what is the molecular formula for a compound that is an empirical formula of HO and a molar mass of 34? What we do is we calculate what I call a formula mass, the mass of the empirical formula. The mass of HO, let's see, H is 1.0 grams per mole, O is 16.0 grams per mole. We add them together and we get a formula mass of 17.0 grams per mole. We now take our molar mass divided by our formula mass, and we get a multiplier. In this case, we would take 34.0 divided by 17.0, and we get a multiplier of 2. Now, simply we take our empirical formula, HO, multiply it by a multiplier, and we get our molecular formula of H2O2.